So, we are starting our course called Probability and Stochastic for Finance Part 2. So, this course would largely be a course on mathematical finance, quantitative finance, and this course would depend on the first part. So, those who have not attended the first part would find a link to the first part in the course page. The interesting fact is that we will not start immediately from very advanced mathematics, which was our mainstay in the last course, but we would rather choose a very simple step. We would take up some very basics idea of the financial market and try to study them, of course using mathematics. And then when we will come to the study of derivative securities, the pricing of derivative securities in a financial market like options and other things like futures, forwards, bonds, etc., then we will pick up from where we had left in the last course. So, essentially this has two parts, this course has, this second part has essentially two parts. The easy part, which we study from a book called Investment Science by D.G. Leuenberger. And the second part, where we talk about derivative securities, we can go ahead and really do more advanced stuff, and several books would be involved at that time. We will tell you later on. So, here we would go largely by this book. So, one of the most important financial instruments that we come across in our daily lives is interest rates. So, everybody is linked with banks. Most of the people who have some income is linked with banks. And one of the things which is crucial to an economy is this notion of an interest rate. For financial market, this notion of an interest rate is of supreme importance. So, what is an interest rate? Why do we pay something called an interest rate? So, this is a sort of financial instrument, a financial principle by which the financial market works. So, interest rate is viewed as the time value of money. So, what does it mean that it is the time value of money? It means the following. It says that, okay guys, have a look. I borrow you say 100 rupees today, and you would take, you say that you would hold it for 1 year or 10 months and give me 10 rupees each. Is this a good proposal? That okay, you give me 10 rupees each. Wow. To a general social emotional setup, it would be a absolutely perfect proposal. But if we are talking about a financial authority like a bank giving you 100 rupees and you want to give in 10 rupees each, they would charge you something called interest rate, because you are holding their 100 rupees for 10 months which they have not been able to invest somewhere else. So, now you also understand that when you deposit a money in a bank account and you keep it holding for some 10 months, 8 months, 1 year, you would see your money grows a little bit. It has some more money than you had actually put in. Here the bank is paying the interest rate, because when you deposit your money in a bank account, you are essentially giving a loan to the bank, and hence the bank is now holding your money, and the bank is paying you back a premium which comes in the form of interest rates. So, interest rates, of course, in real life, borrowing, the rate at which the interest rate for borrowing money from a bank and the interest rate for depositing money in a bank are different. But we will here mathematically, when we model, we will talk about something called an ideal bank where these two are same. So, let us go into the very basic thing. So, something is called a simple interest. So, in simple interest, what the bank does is to announce an interest rate R. So, it is given in percentage, could we say 8%, which is a sort of interest rate on the fixed deposits now in India. So if I have 1 rupee now, so and you say this is the annual interest rate. So, if I have 1 rupee now, then after 1 year this money becomes 1 plus R. Now, suppose you still hold the money for the next 1 year. So, what they will simply do, they will simply, this is called the principal and R is the interest. So, this is the principal. So, you have kept, I have forgotten the symbol, rupee 1 year, and this is the rupee you are getting back, which is 1 plus R. Now, what they will, in the simple interest scenario, what the people will do, the bank people, they will never apply the interest rate on this money. They will apply the interest rate on the given principal and again add whatever you have now got, that interest rate would be added to this in a simple interest scenario. So, the money you get is 1 plus R plus R. So, it is 1 plus 2R. So, here it is very basic, because if you now keep say A amount of rupees A, so after 1 year this becomes A into 1 plus R, because 1 rupee becomes 1 plus R. So, A rupee becomes A into 1 plus R, simple unitary mathematics, it is nothing a basic arithmetic, and then after 2 years it becomes and so on. So, after n years so 1 rupee becomes 1 plus NR. So, A rupee naturally becomes A into 1 plus NR. But this, you see, the growth of the money is linear in terms of R. But suppose you want a much faster growth, because everybody is interested in the faster growth of money. The bank is interested, when he gives you a loan, to take much more money from you than it has actually loaned you. While when you deposit a money, he does not want to give you as much money as you think you should get. So, that is why borrowing rates and depositing rates, interest rates are different, though in an ideal setup it will be the same, because that is where the math becomes easier. So, that is why the bankers invented what is called compounding or compound interest rates. So, what is compound interest rates? Now, what these guys say, okay, after 1 year your principal has now become 1 plus R. Now, instead of charging interest rate on 1 rupee, the original principal, I will now charge interest on the new principal. So, So 1 rupee now becomes 1 plus R after 1 year, and then after 2 years, and 1 year more, 1 year. So basically 2 years. So here also I should write 1 year. So after 1 year more, it becomes 1 plus R into 1 plus R. So this is now the capital A into 1 plus R. So it is 1 plus R square, and so forth. Sorry. So that is the flow of the cash. Now, banks are clever enough. If they take loan from you, they don't do compounding on a yearly basis. They do compounding on a monthly basis. Credit cards absolutely does a compounding on a 20-day basis, right. So suppose you have a whole set of years, this is 1 year period, and then they can divide the whole period into small m blocks, right. Now each of these m blocks, small, 0 plus m, 0 plus 2m, m, 2m and so on. So for each of the 2 blocks, they don't charge you the interest rate R, but the fraction of the interest rate for that particular block. So what they will now do is that if you have 1 rupee, at the end of mth one, the first mth block, you will be charged 1 plus R to the power m, right. And then at the second mth block, you will be charged 1 by R to the power m again. So this will become, after two such consecutive blocks, they have taken, your money now becomes this. Basically that is what happens in the loan. That is why the credit card, things grows very fast. So now what they can do is the following. Now you have m periods in a whole year, then in the whole year, for whole year, this is what you really have to pay back to the, whole year you have to pay back to the bank 1 plus R by m to the power m, because the m blocks the whole year has been divided to. M could be 12, it could be every month, right, but it could be 20 days also. You can imagine what 20 days, how many blocks they would mean, pretty high. That is what credit cards does. They gave you 20-day repayment time. If you do not do, interest is put on, interest is put on. If you do not repay, suppose you repay some X amount, whatever is left, interest is put on. So basically it is assumed that, okay, you haven't repaid back anything, this is what your interest is. Of course, if you repay back, things will go down. See, this calculation what has been done is with the idea that if you have taken a loan, you have not really repaid back, right. Now this is what you will accumulate. Now R is the simple interest rate which is already announced, like 8%. But now the question is, truly have you really been charged at the rate 8% simple interest? So this one R is called the nominal interest rate, which is always announced by the bank. Okay, I am charging you this interest rate. Nominal interest rate. But I bet you will see in your exercises that if you really want to find what is the actual interest rate he has charged me, if I look at the whole thing as a simple interest rate, that after 1 year he has charged me 1 plus R, but he has compounded at every mth interval, right. So let R dash be the actual some sort of interest rate which is been employed on the 1 rupee loan or deposit, whatever, 1 rupee loan, which will finally give me what the bank has charged me. you will always find that this r dash would be bigger than, r dash would always be bigger than r. So, this is called the effective interest rate. So, when a bank is telling you that I will give you in 10% interest rate or 2, they are actually overall yearly they are charging you much more. So, that is the whole idea, this is called the effective interest rate. So, compounding is a very clever way to increase your money. So, when that is why when they will charge you, when they will give you a loan, their interest rate charge would be higher. The personal interest rate charge in a bank is 15%, but if you deposit a fixed deposit, if you fix your money in the bank for a certain period of years, they will give you at a rate of 6%, 7%, right, because there also they have to compound the whole thing. So, in fact, if you fix your money for whole 1 year, this is what you will get. So, that is why when you deposit your money, they give you so less interest rate, because the effective interest rate is always higher. That is the whole point. Okay, you can try it out with some examples which will be given. Also, there is something called compounding at a continuous rate, means my m, these blocks, I made m blocks, say m is say 20, whole year is divided into 20 blocks, m could be 50, m could be 30, m could be 100, m could, or I can be charging you at every 5 minutes, but I can be charging you. So, there is this idea in banks specifically that what happens if you charge at a continuous rate. So, it does not really happen in banks, they actually have some time periods, but from a mathematical point of view, what would happen if you do continuous compounding? What would happen if you do continuous compounding? Continuous compounding is a dangerous thing, because it says basically the money that I should get or the bank should get at the end of 1 year is this, and you know what is the answer to this? What is the answer? The answer to this is e to the power r. You see, though we started with very basic unitary method, we have come to pretty important limit in calculus. So, many banks effectively use this formula. They put you, especially when you are having a loan, they put you on exponential compounding, and that is amazing. That is why when you fail to give money, repay back your credit card loans, you suddenly see that you really have to pay much more than what you thought. It would be equivalent to paying an interest rate of 40%, which is absurd basically, but that what it happens. This is the reason, because they will make m very high, they will charge you for very less time. Now, for example, I could also do something else. I could do the compounding in a slightly different way. I will just rub this spot and do the compounding on this spot. So, I could do the compounding in some slightly different way. So, here the compounding is done in the following way, is that I can divide, for example, the 1 year period into intervals each of a fixed length 1 by m, and then I want to know how much money the bank should take from me if I have invested 1 rupee, or you should give it to me if I have invested 1 rupee or taken a loan from 1 rupee, then they should take from me at the time period t equal to some arbitrary time t. right. It is not just some given 1 year or 2 year or so some arbitrary time t, each interval is 1 by m. So basically now I have divided this into small intervals, so 0 1 here, so each of this, so I have divided this into small intervals of 1 by m each, and let me divide it into m intervals. So I have divided the whole 1 year period into m intervals of 1 by m length each. So if I have m is 12, basically I have divided them into 1 month each, right, 1 by 12. So I will multiply by the 12, so get 1 year. Now what happens if I want to know at any given time t, what is the amount of money I should pay back to the bank or the bank should give it to me, and t should be expressed as some time period k by m. So the time t should be some k, approximately some k into 1 by m to do an effective calculation. Okay. So there are m periods. So basically what I will now do, the amount of money I have to pay back at the end of one period is 1 plus r by m, because m is the number of periods. Now what we have to do is that so I do it for k periods, right. Here I have done it for m periods, I could have done it for 2 periods, 3 periods, 4 periods. So suppose I have done it for k periods, where this k is the period, so t is the time, any time I have given, so any time t I have fixed, any arbitrary time in the year. So how many periods I have crossed? So we take basically the lowest integral one, not the higher integral one. Basically it should be some sort of this sort of thing, or rather it should be k should be mt, this sort of thing. So now I have, this is the amount I should pay for that k period, right. But what is k? K is actually some sort of m into t. So I will just assume that I have been able to get a k is a m, and t has been chosen in such a way that okay, I am getting an integer for the time mean. So now as m goes to infinity, how much should I be paid, how much should the bank ask from me at the end of the time t? It should ask from me as t tends to infinity, I pay or bank pays e to the power r t, because the limit of this is e to the power r t. M tending to infinity, of course, sorry, thank you. As m tends to infinity, so as I increase this number of partitions, I may make the partition smaller and smaller, which means I am making these lengths, I am making m, the number of m is larger and larger, and hence these partitions are made smaller and smaller and smaller, means I am asking you for money at almost every interval, then this is every second possibly, then this is the amount essentially I have to pay at the end of time t. At when t is equal to 1, the whole year, then I pay e to the power r. So when t is 1, you pay e to the power r. So if t is t, which is less than 1, you pay e to the power r t. So you pay less. Okay. Now we will talk about something called present value, future value, and their relationships. We will first talk about what is called a present value. A present value of a certain amount of money. So So, this is a very important concept and it will be seen throughout our study of finance. Of course, we are doing quantitative things, it is mathematical modeling where idealizations would come in which may seem to be off track, there has been off track from the reality. Of course, you cannot model reality with mathematics because if you look at physics, you know, it's so difficult to model reality, it's so complex. And here because there is the issue of human interaction, modeling is really a tough game, and that's the real issue of in economics, how to use more effective mathematical models. But finance is still much more organized, and so mathematical models tend to work much better. Okay. Now, I will talk about present value. Present value is, okay, how much money I should invest now to get rupees 110 after 1 year. So, I am going to talk about this important question. So, I want to have So, from a very simplistic point of view, if I take 100 rupees and invest in a bank which gives me a 10% rate of return, then in a very simple situation, right. So, 100 into 1 plus R 10%, so R is 10%, so 10 by 100, so it will become equal to 100 plus 10, which is 110. So, if I now give 100 rupees, now pay 100 rupees to a bank, then after 1 year if the bank actually gives me at a rate 10%, I will get back 110. If it gives me lesser one, I have to invest a slightly more money, less if the interest rate is less. So, this 100 rupees is what I call the present value of 110 rupees. It is the 110 rupees after 1 year, now what 100 rupees to me if a bank gives me a 10% interest rate for holding the money, keeping the money, right. So, if my interest rate is R, right, and I want to have 1 rupee after 1 year, what should I do? I should invest 1 by 1 plus R, because now this money after 1 year the bank should pay me, this is A into 1 plus R, and that will give me back 1 rupee. So, this 1 by 1 plus R quantity is called the present value of 1 rupee. So, if I want to get 1 rupee after 1 year, now I have to invest 1 by 1 plus R amount of money. This is the idea. So, this is a very, very important idea which is there in all our finance. So, what would happen if I am talking about compounding, right? So, if I want to talk about compounding, if instead of this interest rate I talk about a compound interest rate, say for 12 years. So, I have M as 12. So, 1 by, so I have 12 periods, right. So, then if I invest this amount of money 1 by 1 plus R by 12 rupees, if I invest now and if R be the nominal rate and this is my, I have this 1 monthly compounding, then I will get after 1 year 1 rupee. So, now if the bank gives me compounding interest rate, this is my present value of the rupee 1 after 1 year is now worth this amount. So, it worths you less now. So, something which worths you some x rupees now, if you hold it in a bank, because you will get some positive money, extra money, that so that would increase the current value of the current money. So, you always hold some lesser money in a bank now, which will give you some higher money later on, right. So, this is called present value. We will now come to the discussion of what is called an ideal bank, because our discussion of finance throughout, whenever we talk about bank or money markets, would come through the concept of an ideal bank. So, what is an ideal bank? Ideal bank is a bank where the rate of interest R remains same whether you deposit cash with it or you take a loan from it. So, ideal bank is rate of interest remains same for deposits and loans. Meanwhile, you have to understand that the interest rate might change if you, for example, change your period of holding. Suppose you want to have a 2-year, you want to keep money for in a bank for 2 years, or you have bought a fixed deposit for 3 years, then the interest rate would be something else. And if you put money for 5 years, then the interest rate would be something else. But now suppose you have put money in a fixed deposit and then interest rate is R. But you take the same money with a same money as loan with a 3 years repayment period, then the interest rate should also be R. So, that is the meaning of a ideal bank. So, essentially the term which is often used is called a constant ideal bank, because the rate of interest remains constant for both these cases, whether it is loans or deposit. So, this is sometimes also called constant ideal bank, but we will just call ideal bank to mean that okay, for a certain type of transaction, the interest rate of deposit or interest rate of taking loan, reversing the procedure, is same, the way I have just explained now. Okay. So, there is something called future value and present value of a cash flow stream. What is a cash flow stream? Now, suppose I am a salaried person, right, and I am getting money every year, every month actually I am getting salary. So, I said okay, this month I will keep X naught amount of money and put it in the bank. Next year I will get, next month I will take X1 amount of money and put it in the bank, and I assume that they will give me simple interest rate. The compound, it is fine, I am just taking at a very simple statement, simple interest rate. I put some more money in the X2 money in the bank and so on and so forth. So, something is called we will stop our discussions by talking about the present value of a cash flow stream and the future value of a cash flow stream. So, cash flow stream is the amount of money I am receiving. It could be that I am receiving at 1 month and giving in some month, that could be. So, it is a cash flow stream. So, there is a flow of cash. Suppose this is my year, say first month, second month, third month, fourth month, fifth month, sixth month, I can do up to nth month or nth periods actually. So, here I have a cash flow x naught, here I have a cash flow x1, it could be outside also, I could be giving money. Here I could be having cash flow x2 or x3, x4 and so on. So, basically I have a cash flow. So, I do it for n months. So, how much money I will get at the end of n months? So, that is called a future value of the cash flow, right, which is very natural. So, if I have x naught now, I keep in the bank up to n months, I will get this money. the x1 money I can hold up to only n minus 1 month, because after n months I am taking out the money. So, this will be plus xn, xn is the money where I have deposited the nth month and there will be no interest rate because I will take it up. Similarly, something is this is called the future value. There is similarly something which is called the present value, right. So, now suppose I have the same cash flow, what would be the present value of the stream? R is the interest rate. So, the present value is, if I have x naught, this is my present value at 0th period. I am at 0th period, I am looking at the value of the, so I am expected that I will receive this amount of money, right. So, the period, the value which I will receive at time 1, at time 0, its value is, okay. So, here if I pay so if you look at this, for example here, so at the this money is my present value of this xn cash flow. So, now xn is I am getting after n periods. So, if I multiply by 1 plus r to the power n, I will get back xn. So, that is why that is called a present value. x1 is I am only holding it for, I am getting it in the next month. So, I just want to know how much money I should invest now, I should have now, so that next month I get x1. If I have this money, so next month I will have x0 plus x1 with me. So, basically it is the total, so it is the current worth of the stream of cash flow that is going to come to me. This is the cash flow that is going to come to me, and here it is the opposite. I know that these are the cash flows are going to come to me, and after n period what I am going to get. Or I know that this is the cash flow that is going to come to me, then what is the, if you look at the formula very carefully, you will find that there is a very interesting relation between FB and PV, and the relation is that the present value is nothing but the future value by 1 plus Rn. This present value and future value, these are very important concepts. So, we are not going to deal with too much of issues today. What we are going to do is put as an exercise certain concept called internal rate of return. So, internal rate of return is a very interesting concept. It says that suppose my cash flow consists of some deposits and takeouts from a bank. I am depositing in a bank and withdrawing from a bank, some deposits and withdrawals from a bank. So, basically the rate of interest is R. Now, what rate of interest I should have if my current worth of the future flow of money is 0? Okay. So, now suppose I want to have these cash flows, this could be 0 actually. Suppose my present value is 0, PV is 0. What interest rate should I have so that the PV, the present value, present worth of this cash flow is 0, right. Because here you are not doing anything with the bank, you are not fixing up any loan, you are not taking any loan, or not you are giving a fixed deposit, you are just transacting on the account. So, your present value of your transaction is actually 0, you have not done anything to a bank, you have just taken from your account, given back to your account. So, what sort of rate? That is called the internal rate. So, if what is the value of R for which PV is equal to 0, that is called the internal rate. So, that is something interesting which we will teach you through exercises. And there is something called the main theorem on present value. So, if you have two cash flow streams, so X and Y, so this is cash flow consists of x0, x1 to xn, and this cash flow consists of y0, y1 to yn. So, if you have interest rate R and you use these monies either to, for example, you have constantly this money is coming to you for n months and you want to deposit this money constantly in a bank and see how much you get, or you want to calculate its net worth. So, two cash flow streams are equivalent if their present value is same. So, on the given interest rate R of a constant ideal bank, if two cash flows have the same present values, then they are equivalent. So, means you can choose this cash flow or that cash flow. So, means when can you transform a cash flow, this cash flow to this cash flow, means when is it same as taking these two cash flows, it is same as taking this cash flow or that cash flow, your present worth of both the cash flows should be same. So, if present worth of both the cash flows are same, we call such cash flows equivalent cash flows. Because what I can do, if the net values, so suppose I know the present value of the cash flow is some PVX. So, I can just put PVX in my bank and forget, and don't just put anything here, I will get back, and the next cash flow is 0, 0, 0, 0, 0, right, and I can put PVY here and then I can put 0, 0, I have no cash flows at all. So, and then if I put that in the bank, that is exactly my present value. If you write down the present value of this and you write down suppose I have a stream like this, PVX 0, 0, 0, 0, the present value of this and the present value of x0, x1 the present value of these two streams are equal. So, this PVX is the present value of this stream. So, this cash flow is same as this cash flow. So, if I keep this amount of money and do not do anything, the present value of that cash flow is same as present value of this particular cash flow where I am getting x0, x1, x2 dot 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 xn of supply. So, with this we have some idea of interest rate, and we will start working on other aspects in the next classes. So, some of the issues will come to you through little problems. Maybe we will talk a bit about fixed income securities in the coming classes, or whatever is left for interest rates. So, I hope you have some general idea of what we have tried to do here. Tomorrow I will start with some very basic result, and this is a very important result. This is called this is one of the major result, because it is called the main theorem on internal rates of returns. So, tomorrow I will try to give you that theorem, maybe give a proof. Internal rate of return happens, the rate at R, rate of return R, or the interest rate R, interest rate is sometimes called the rate of return. So, what is the interest rate for which this is 0? So, tomorrow we will start with this and then we will try to do some related things. So, I hope you have some idea about the whole thing and maybe we will continue tomorrow. Thank you.